Hello there, and welcome to the Sleepy Space Channel. Deep space holds no walls, and it springs no traps. What makes it unsettling is simpler than that. It is the distance, and the way each step outward is harder to come back from than the last. Cross the gulf to the nearest star, and you will have traveled for longer than all of human history. Go further still, and you meet worlds with no sun, stars crushed smaller than a city, and places from which not even light can return. The farther out you go, the emptier it grows, the stranger the things adrift in it, and the less any of it would ever let you come home again. If you find these explorations worth your time, a like or a subscribe helps the channel reach others who do. Thank you for being here. But for the next couple of hours, none of this is a distance you need to cross. Settle in. Let your shoulders soften. Let your breathing slow. Let the day fall away behind you, and let the quiet carry you gently towards sleep. Let's begin. Part 1. The First Darkness. Begin with the ground beneath you, and how completely it holds you up. The floor carries your weight without effort. The air moves in and out of you without a thought. Around you, the temperature sits in the narrow band that a living body can bear, and light of a friendly color falls on everything you can see. All of this feels ordinary, the plain background of an ordinary night. Yet almost nowhere else in the universe is anything like it. The warmth, the air, the gentle light, the solid floor are not the normal state of space. They are a rare and delicate exception, and the journey we take tonight begins by quietly leaving that exception behind. Rise upward from the surface, and the comfort thins almost at once. Only a short way overhead, the air grows too faint to breathe, and a little higher it fails altogether. There is no wall between the sky and space, no line painted across the blue. There is only a fading, a steady thinning of the air, until, a few hundred kilometers up, so little remains that the sky above turns black in the middle of the day. The stars no longer flicker there, because there is almost no air left to make them tremble. From that height outward, in every direction, the ordinary substance of the world simply runs out. Consider how quietly this happens. You do not travel for years to reach the dark. The emptiness that fills nearly all of space begins just above the thin shell of air that wraps the earth, closer to you than many cities are. Below that shell is everything you have ever known. Above it is almost nothing at all, stretching outward without end. It is a strange and slightly sobering thought that the boundary between the living world and the great vacuum is so near, and so thin, and so easily crossed by anything moving upward. Move past that boundary, and the true scale of the solar system begins to show itself, and its first lesson is emptiness. We picture the sun and its planets as a crowded family, gathered close. The truth is almost the opposite. If the sun were shrunk to a marble set on a table, the earth would be a grain of sand a full stride away, and the next worlds would be smaller grains scattered across the whole room. Between those grains there would be nothing, no other marbles, no dust, only the wide and patient dark. The solar system is not a crowd. It is a handful of specks in an enormous and mostly empty hall. As we travel outward, the sun itself begins to change. It does not go out, and it does not dim all at once. Instead, it shrinks, slowly and steadily, because its light spreads thinner the farther it has to reach. Double your distance from the sun, and its warmth and brightness fall to a quarter of what they were. Travel far enough, and the disk that fills our daytime sky becomes a smaller disk, then a brilliant point, then merely the brightest star among many. The sun does not abandon a traveler. It only recedes, like a lamp left burning in a window as you walk away down a long and darkening road. The space we are moving through offers nothing to hold on to and nothing to slow us down. There is no air here to carry a sound, so the loudest event imaginable would happen in perfect silence. There is no substance to carry warmth from one place to another by touch, so heat can only leave a body as a slow glow, drifting away as light. A traveler set moving in this emptiness would continue in the same direction, at the same speed, with nothing to push against and nothing to push back, drifting onward for as long as the dark allowed, which is to say, almost forever. It would be a comfort to think that this near-Earth dark, at least, is a safe and gentle place. It is not quite either. The sun blows a constant thin wind of charged particles outward in all directions, sweeping past every world in its family. Radiation born in far more violent places streams inward from the deep and passes through nearly everything in its path. The emptiness close to home is not soft and it is not kind. It is simply quiet and still and indifferent, going about its nature whether or not anyone is present to feel it. Even the distances between neighboring worlds are larger than they seem. Light, which crosses the whole of a room in less time than we can measure, needs minutes to reach us from the sun, and long minutes more to bridge the gaps between the planets. Our own moon, the nearest body in all the sky, is far enough that its light takes more than a second to arrive, and a fast journey there still takes days. The planets are not close companions passing in a lane. They are lonely islands, each one riding its own wide orbit, separated by gulfs that would swallow 1,000 Earths and never notice. There are other quiet strangenesses to the vacuum near home, beyond its emptiness. With no air pressing in from outside, ordinary liquids do not stay liquid. They boil away even while they are cold, because nothing holds them together. Sound has no way to travel, so the most violent events happen in total silence. And without air to scatter it, sunlight does not fill the sky with blue. In space, even close to the Earth, the sun blazes against a sky that stays perfectly black, and the stars and the sun can be seen together at the same time, the day and the night folded into one. Motion, too, behaves in ways the ground never taught us. A body in orbit is not held up by anything. It is falling continuously, curving around the Earth so fast that it keeps missing the ground beneath it. There is no felt sense of up or down, no floor to press against, only a long, weightless drift. The first darkness is not merely empty of things. It is empty of nearly every ordinary rule we grew up trusting, and a traveler entering it must set down almost everything the solid world taught about how the world behaves. Temperature, too, turns strange without air to even it out. On Earth, the atmosphere carries warmth from the sunlit side to the shadowed side and softens every extreme, but in the vacuum there is nothing to do this work. A surface in direct sunlight can grow scorching, while a surface in shadow, only a step away, falls to a deep and bitter cold, the two extremes sitting side by side with nothing between them to share the difference. In space, sunlight and shadow are not merely bright and dim. They are two separate and unmixed worlds of heat and cold, divided by the thinnest of lines. For all of this, the near dark is not a frightening place, only an honest one. It asks nothing of the traveler passing through it. It makes no sound, sets no traps of its own, and holds no ill will. It simply is what it is, the first and shallowest layer of the emptiness that fills the universe. And it is only the beginning. Ahead of us the dark grows deeper and colder and stranger with every step, and the warm world we started from grows smaller behind us. So let us go on, gently, outward past the planets, toward the places where the sun is no longer the source of day. Part 2. The Outer Dark. Travel outward past the inner worlds and the character of the light begins to change. Near the sun there is warmth enough to melt rock and boil away ice. Farther out, past the middle of the planetary family, the warmth fades until ice becomes the ordinary state of things, and whole worlds and moons are built from frozen water and frozen gas. This is the beginning of the outer dark, the great cold country of the solar system, where the sun still shines but no longer truly warms, and where day is only a memory of a brighter place left behind. Out at the orbits of the farthest large planets, the sun has shrunk to a point. It is still the brightest thing in the sky by far, far brighter than any other star, but it is a point of light and not a disk. Noon on a world out here would look dimmer than a moonlit night looks to us. The light that falls is pale and thin and gives almost no heat, and the temperature settles toward 200 degrees below the freezing point of water and lower still. In this country, cold is not a season. It is the permanent condition of everything. Beyond the last of the great planets lies a wide, cold ring of icy worlds, a region far broader than the whole zone of planets we have just crossed. It is filled with frozen bodies large and small, with dwarf worlds and countless smaller fragments, all of them left over from the making of the solar system and preserved in the deep freeze ever since. We might imagine such a ring as crowded, a field of tumbling ice. In truth, its members are so widely spread that they are separated, each from the next, by tens of millions of kilometers. Even in the ring, the dark far outweighs the ice. On one of these distant frozen worlds, the idea of daytime quietly dissolves. There is no warm disk crossing the sky to mark the hours. There is only that brilliant point of a sun, bright enough to cast the faintest shadows, moving so slowly and giving so little that it can hardly be called day at all. A traveler standing there would feel no warmth on an upturned face. The sun would be a beautiful and distant thing, the source of every warm memory, and utterly unable to reach across the gulf that now separates them. Distance out here begins to weigh on even the fastest thing there is. Light, which we are used to thinking of as instant, takes hours to cross this part of the solar system. A message sent inward from these frozen worlds would reach the Earth only after a long delay, and any reply would take just as long to return. Out here, a conversation would be measured in half-days of waiting. Even light, the swiftest messenger in the universe, begins to seem slow, worn down by the sheer size of the emptiness it has to cross. The few machines we have sent this far took decades to arrive. They are the fastest objects our species has ever launched, flung outward with everything we could give them, and still they crawled across the outer solar system over the better part of a human lifetime. And for all that effort, by the measure of the wider universe, they have barely left our doorstep. They are still, in every cosmic sense, right beside us. The distances ahead of them are so much greater than the distances they have already crossed, that the journey so far hardly counts as a beginning. Look back from out here, and the Earth is no longer a world at all. It has become a point, a pale speck almost lost in the glare of the shrunken sun beside it. Everything that has ever happened, every life and every story, is gathered on that single dim mote, small enough to hide behind a raised thumb held up against the dark. There is something quieting in the sight rather than frightening. From the outer dark, all the noise of home falls silent, folded down into one small point of light, adrift in a very large night. This cold country is where the solar system stops being a place of worlds and starts being a place of distances. The planets are behind us now, each one a lonely island we have passed. Ahead, there are no more great worlds to break the emptiness, only the thinning ring of ice, and then the boundary where the sun's own wind finally gives out. The dark here is deeper than the dark near Earth, and colder and wider, and yet it is still, remarkably, only the near edge of the sun's family. We have not yet truly left home. The last outposts before the true cold are the giant planets and their crowds of moons. These moons are worlds in their own right, some of them wrapped in ice, and beneath that ice, in one or two cases, there may lie hidden oceans of liquid water, kept from freezing by the slow flexing of the moon as it circles its giant. It is a strange thought that some of the last possible homes for liquid water in the outer solar system are not warmed by the sun at all, but by the patient squeezing of gravity, far out where sunlight has almost failed. Beyond them, in the frozen ring, drift the dwarf worlds, small and dim and unimaginably cold. They move so far from the sun that a single circuit of their orbit can take 2 or 3 human lifetimes, or many more, a slow and lonely lap through the dark. Their surfaces are painted in frozen gases that on Earth would never be solid at all, and their skies, if you stood upon them, would hold a sun no larger than a bright star. Out here, the year loses all human meaning, stretched into centuries by the sheer size of the orbit. The gaps out here are so wide that crossing them is an act of patience. A craft, leaving one giant planet for the next, travels for years through open dark, with nothing to pass, nothing to see grow nearer for a long while, only the slow shrinking of the sun behind and the slow swelling of the target ahead. The outer solar system was the last part of our own neighborhood to be visited at all, precisely because it is so far and so empty, and even now only a handful of machines have ever crossed it, threading the enormous distances between its few scattered worlds. So we drift onward through the frozen ring, past the last of the tumbling ice, letting the sun grow smaller still behind us. There is no hurry in this country, and no danger that reaches for us. The cold is simply the cold, and the distance is simply the distance, and both of them go on growing as we travel. Ahead lies the place where the sun's reach at last runs out, not with a wall, but with a quiet fading, the true border of everything the sun still rules. Let us go softly toward it, and see where the light of home finally lets go. Part 3. Where the sun's reach ends. The sun does more than shine. It breathes outward a steady wind of charged particles, flung off its surface and streaming away in every direction at enormous speed. This wind fills the space around all the planets, blowing far past the frozen outer ring, inflating an immense bubble around the whole solar system. Inside that bubble we are, in a real sense, still within the sun's own outer atmosphere, thin and stretched though it is. Everywhere the solar wind reaches, the sun still holds a kind of gentle authority over the dark. This bubble is enormous, but it is not endless. Far beyond the last planet, the solar wind finally slows. It has been pushing outward against the thin gas that lies between the stars, and at some great distance, that gas pushes back hard enough to bring the wind to a halt. There, the sun's breath piles up, tangles and stops. It is a real boundary, a shell around the whole solar system, marking the farthest place the sun's wind can clear a space of its own. Past it, the sun no longer sets the terms. You could not see this boundary if you were there. It is not a wall, not a shimmer, not a line of light. It is a change in what the emptiness is made of. On the near side, the thin particles drifting past belong to the sun, carried out on its wind. On the far side, they belong to the galaxy at large, the gas and dust of interstellar space that the sun has spent its whole life pushing back. Crossing that shell means passing from the sun's own territory into the common dark that lies between all the stars. Only a small handful of machines have ever crossed it, and they felt the change not as a jolt but as a slow shift in the tone of the emptiness around them. The count of the sun's particles fell away. The count of the galaxy's particles rose. The magnetic field that had guided everything for the whole journey loosened its grip and gave way to a different field, one belonging to the wider galaxy. It was, in every measurable way, a border crossing, quiet and invisible, registered only by patient instruments in the dark. What lies beyond this shell is the first genuinely foreign country of our journey. Until now, however cold and empty the dark has been, it has still been the sun's dark, swept by the sun's wind, lit by the sun's fading light. Past the boundary, that is no longer true. The traveler enters space that belongs to no star in particular, the general emptiness between the stars, where the sun is only one bright point among the scattered many and holds no special power at all. It is the true beginning of interstellar space. There is a kind of shelter that is lost at this boundary, and it is worth naming gently. The sun's magnetic bubble does more than mark territory. It deflects a large part of the harshest radiation that streams in from the violent deaths of distant stars, shielding everything within it, including the Earth, from the full force of the deep. Beyond the bubble, that shelter is gone. The galaxy's weather blows unobstructed there, a steady rain of fast particles from far away, and nothing softens it. The sun protects its family farther than we often realize, and this is the place where that protection finally ends. And still, for all that it marks the end of the sun's reach, the boundary is not a frightening place to be. It is silent and slow and almost featureless, a soft handing over from one kind of emptiness to another. A traveler would notice nothing dramatic, only the gradual sense that home lies behind and the open dark lies ahead. The sun would still be visible, still the brightest star in that sky, but it would be a star now and not a sun. The word itself would begin to feel too large for the small bright point it named. Think of how far we have come to reach this edge, and how far it still is from anywhere else. The boundary of the sun's wind lies far beyond the last planet, far beyond the frozen ring, at a distance that took our fastest machines decades to reach. And yet the nearest other star is hundreds of times farther still. The sun's whole domain, enormous as it is a small bright island, and around it stretches an emptiness so much larger that the island nearly vanishes within it. We have reached the shore of home, and the ocean beyond it has no far side we could ever hope to touch. This bubble around the solar system is not a neat sphere. Because the sun is itself moving through the galaxy, plowing forward through the thin gas between the stars, the bubble is shaped by that motion, with a rounded, blunt front where it presses ahead and a long, drawn-out tail trailing behind, something like the shape of a wake around a boat. We sit inside this slow-moving cocoon, carried along with the sun, sheltered within a shape that the sun has been carving through the dark for as long as it has existed. The boundary also breathes. The sun does not shine and blow with perfect steadiness. Its activity rises and falls over a long, regular cycle, and as it does, the pressure of its wind swells and eases. The great bubble expands and contracts in answer, its outer edge pushing outward when the sun is lively, and drawing back when the sun is calm, flexing slowly over the years. The edge of the sun's country is not a fixed line, but a living boundary, swelling and settling with the long, quiet rhythm of the sun's own moods. There is, in truth, more than one boundary out here, layered one beyond the other. First, the rushing solar wind meets a place where it must slow abruptly, piling up as it presses against the resistance of the space beyond, and only farther out does it reach the final edge where it stops altogether and gives way to the gas of the galaxy. A traveler would cross first the place where the sun's breath falters, and then, much farther on, the place where it ends, passing through a broad and turbulent frontier region rather than a single clean line. So we pass through the boundary softly, feeling the sun's wind fall away behind us, and let the common dark of the galaxy open ahead. There is nothing here to fear and nothing here to reach, only the quiet fact of having crossed from one country into another. The sun is a star now, small and steady at our backs. Ahead lies the true gulf between the stars, deeper and emptier than anything we have yet crossed. But before we enter it fully, there is one more part of the Sun's family to pass, a great and ghostly shell of ice that reaches almost halfway to the next star. Part 4. The Comet Cloud. Before the true gulf between the stars opens, there is one last part of the Sun's family to cross, and it is the strangest of them all. Surrounding the entire solar system, far beyond the last planet and far beyond the boundary of the solar wind, astronomers believe there lies an immense shell of icy bodies wrapped around everything in every direction. It is not a ring lying flat like the belt of ice we passed earlier. It is a hollow sphere of frozen worlds, enclosing the Sun and all its planets like the faint shell around a seed. From it fall the long comets that now and then drift into our skies. The size of this shell is difficult to hold in the mind. Its inner edge may begin thousands of times farther from the Sun than the Earth is, out where the planets are only a memory. Its outer edge may reach something like 1.5 light-years into the dark, which is nearly halfway to the very nearest star. The Sun's true family, then, does not end at the last planet, or even at the edge of its wind. It reaches outward, across a good part of the distance to its stellar neighbors, a ghostly sphere light-years wide. We call it a cloud, but that word paints the wrong picture. A cloud in the sky is thick and soft and full. This shell is almost entirely empty. Its icy members are so thinly scattered that each one may be separated from its nearest neighbor by tens of millions of kilometers, a distance greater than many gaps between the inner planets. If you stood upon one of these frozen bodies and looked around, you would almost certainly see no other. You would see only the distant Sun, shrunk to a bright star, and in every other direction, the deep and patient dark. Time itself stretches strangely out here. A comet falling inward from the outer part of this shell can take millions of years to complete a single slow loop around the Sun. Some of the comets that drift past us now were last near the Sun long before there were any people to look up and notice them. Others, swinging outward on their long paths, will not return for 100,000 years or more, by which time this night, and everything in it, will be so far in the past that no memory of it could possibly remain. The shell keeps a calendar measured in ages, not in years. So far from the Sun, the grip that holds these icy worlds in place is gentle, almost tenuous. The Sun still pulls on them, but weakly, and other forces can compete with it. A star passing at a distance, or the slow, patient tide of the whole galaxy turning, can reach into this shell and stir it. Some bodies are nudged inward to begin the long fall that will one day bring them past the Sun as comets. Others are loosened the other way, pulled free of the Sun altogether, and set adrift into the space between the stars, lost from the family forever. We have never seen this shell directly. It is too far and too dark, its members too small and too widely spread to catch in any image. Everything we believe about it, we have pieced together from the comets that fall inward, tracing their long paths backward to guess where they must have come from. It is a part of our own solar system that we know only by its messengers, a country we have never visited and cannot see, inferred entirely from the few frozen travelers that wander in from it toward the warmth. The edge of home is, in the most literal way, a place of rumor. Consider what it would mean to cross this shell as a traveler. Having already left the last planet decades behind, and having passed the boundary of the Sun's wind, you would enter the inner edge of the comet cloud and travel through it for thousands of years, and in all that time you would still, technically, be inside the solar system. The Sun would still hold you, faintly. Home would still, by the old definition, surround you. The dark you were moving through would still be, in name, the Sun's dark. And you would cross it for a span longer than all of human history before reaching its far side. There is something quieting in that thought, rather than frightening. The edge of the Sun's family is not a sharp line to be feared and crossed in an instant. It is a light-year-deep shell of frozen quiet, so wide and so slow that a journey through it becomes its own kind of stillness. Nothing there reaches for the traveler. The ice simply drifts, the sun simply shines its small, far light, and the ages simply pass, one after another, without event. It is the gentlest of borders, made of nothing but distance and time and cold. The great shell is thought to have two parts, blending into one another. Nearer in lies a flatter, thicker region, and far beyond it the enormous spherical cloud that reaches toward the next star. From these frozen reserves, now and then, a single body is nudged loose and begins to fall inward, and if it falls far enough toward the sun, it wakes. The cold ice begins to warm and turn to gas, unwrapping the body in a glowing haze and streaming it out into a long, bright tail. What we call a comet is one of these shell dwellers, briefly roused, on a rare visit to the light. After that brief passage through the warmth, the comet swings back out and returns to the deep cold, its tail fading, its ice refreezing, carrying it once more into the dark for ages before it comes again, if it ever does. And because the outer shell is held so loosely, it is not entirely the sun's alone. The slow tide of the galaxy reaches into it, and passing stars tug at its edges, so that the far frontier of our solar system is, in a sense, a shared and shifting border, mingling quietly with the dark that belongs to our neighbors among the stars. Every great comet that has ever crossed our skies and stirred those who watched it was a traveler from this frozen edge, a single icy body roused from the deep cold and sent falling inward toward the light. Each arrives, brightens, unfurls its long tail, rounds the sun, and departs again into the dark, not to be seen for thousands or tens of thousands of years, if ever. The brief brightness of a comet in our sky is the far shell of the solar system briefly reaching in to touch us, a rare visit from a country we can never go to meet. And yet, once we pass beyond it, the last thread of home is finally behind us. Past the outer edge of the comet cloud, there are no more icy bodies that belong to the sun, no more shells or boundaries that the sun has made. There is only the open gulf between the stars, deeper and emptier than anything we have yet crossed, belonging to no star at all. So let us drift out through the last of the frozen shell, watching the sun dwindle to just another point of light behind us, and enter the true dark between the stars, where the real distances of the universe begin. Part 5. The Gulf Between the Stars. Now, at last, we are outside the sun's family entirely, adrift in the space between the stars. This is the emptiness that most people picture when they imagine deep space, and yet the reality is emptier than nearly anyone imagines. On the average, across the enormous gulfs between the stars, there is only about one atom in every cubic centimeter of space. A thimble of this emptiness holds a single atom, where the air you are breathing holds numbers so large they cannot be written on a page. The space between the stars is thinner than the finest vacuum ever made in any laboratory on Earth. Our own corner of this emptiness is thinner still than most. The sun happens to sit within a large region that was swept unusually clean long ago, cleared out by the explosions of ancient stars that lived and died before us. Their blasts pushed the thin gas of the galaxy away in all directions, leaving a great, quiet cavity, and the sun drifts through the middle of it. So the dark immediately around us is not merely empty. It is a hollow within the emptiness, a clearing in an already sparse and silent country. In this gulf, there is nothing to give warmth, and so it is profoundly cold. Far from any star, with no fire near enough to matter, the temperature falls to only a few degrees above the coldest possible cold, the absolute zero below which nothing can go. What little warmth exists here is not sunlight at all. It is the faint, even glow left over from the birth of the universe itself, a whisper of heat spread through all of space, holding everything just barely above the bottom of the scale of cold. That ancient warmth is the only fire that reaches this far. For all its emptiness, the gulf between the stars is not perfectly still or perfectly bare. Vast fragments of atoms, flung out long ago by the violent deaths of distant stars, race through it at nearly the speed of light, crossing the dark as a thin and constant rain. Here and there, over enormous distances, the sparse gas and dust gather into faint, cold clouds, so tenuous you could pass through one and never know, and yet dense enough that within them, over ages, new stars will slowly gather and one day catch fire. The empty country is not dead. It is only patient. What the gulf lacks most is any sense of place. Within the solar system there were always landmarks, planets to pass, a sun to steer by, a sense of moving from one thing toward another. Out here there is almost nothing to mark progress at all. The stars are so far away that they hardly seem to shift, however fast you travel. A journey of years would leave the star field looking very nearly the same as when you began. The traveler moves at enormous speed through an emptiness so large that motion itself becomes hard to feel, and the dark seems to hold perfectly still. It is worth pausing on how complete the silence is here. There is no air to carry a sound, and no surface to stand on, and no light but the far cold stars and the faint glow of the beginning. Nothing moves that a traveler could see. Nothing changes from 1 hour to the next, or 1 year to the next. The gulf between the stars is the stillest place we have yet reached, an emptiness so deep and so quiet that the mind reaches for something, anything, to hold, and finds only the steady, distant lamps of stars that are themselves too far to ever touch. This is the true scale of the dark, the thing that the near emptiness only hinted at. Everything before this, the space between the planets, the frozen ring, even the light-year shell of comets, was the sun's own country, thinly held but held. This is not. This belongs to no one, and it stretches between every star in the sky, a common ocean of near-perfect nothing in which the stars themselves are only scattered islands. To be here is to understand, for the first time, how much of the universe is simply distance, cold and quiet and unmarked. And still the gulf is not a hostile thing, only an honest one. It does not reach for the traveler or wish them ill. It is empty, in the way that a still night is empty, holding nothing and asking nothing. The unease it stirs is not the fear of any danger, but the plain vertigo of scale, the feeling of being very small in something very large. That feeling, faced gently, softens into a kind of peace. There is nothing to do out here, nowhere to hurry to, only the long, quiet drift through the dark between the lamps. The thin gas between the stars is not all the same. In some places it is relatively warm and spread evenly. In others it gathers into colder, denser clouds. And in still others, swept by the blasts of dying stars, it is heated to a thinness and a fierceness all its own. Starlight drifts through it, and the fast rain of cosmic particles stirs it, so that even this near emptiness is quietly alive with slow processes, gathering here, dispersing there, over spans of time so long that to us it seems perfectly and permanently still. And nowhere in it is there ever truly nothing. Even the emptiest reach of interstellar space is bathed in the faint, even warmth left over from the birth of the universe, a whisper of heat that fills all of space and touches everything, however far from any star. There is no corner of the dark so remote that this ancient glow does not reach it. The gulf between the stars is the closest thing to true emptiness that most of the universe offers, and even it is gently lit, everywhere, by the fading warmth of the beginning of all things. Our own sun is not fixed in this thin gas but drifting slowly through it, wandering across the local emptiness over enormous spans of time. Right now it is passing through a faint wisp of slightly denser gas, one small cloud among several that lie near one another in this stretch of the galaxy, and over tens of thousands of years it will drift on out of this wisp and into the clearer emptiness beyond. Even our place within the gulf between the stars is not permanent. We are travelers through it, moving quietly from one thin cloud to the next, never truly at rest. We have entered the gulf, but we have not begun to cross it, and the size of the crossing is the next thing to reckon with. The nearest star to the Sun is out there ahead, a single point of light among the many. It is the closest neighbor we have, the very first stop on any journey between the stars. And even that first step, the shortest crossing the galaxy offers, is longer and lonelier than almost anyone imagines. So let us turn toward it and measure honestly how far away the nearest star really is. Part 6. The nearest star and the length of the crossing. The nearest star to our Sun lies a little more than 4 light-years away. The number sounds almost small, 4 of something, until you unfold what a light-year truly is. It is the distance light travels in a year, moving at the fastest speed the universe allows, never slowing, never resting. Light crosses from the Sun to the Earth in minutes. To reach the nearest other star, that same light must travel on, at that same impossible speed, for more than 4 full years before it arrives. And that star is our closest neighbor of all. Now measure the same crossing by the standard of our own machines. The fastest craft our species has ever built, moving at speeds that would carry them around the whole Earth in minutes, would still need tens of thousands of years to reach that nearest star. Tens of thousands of years is longer than all of recorded history, longer than the time since the first cities were built, longer than the memory of our kind reaches in either direction. The shortest possible journey between 2 stars is longer, by our real means, than civilization itself has so far lasted. Imagine the loneliness of such a crossing. For the whole of that immense journey, there would be no sun near enough to give any warmth. Behind the traveler, the Sun would be a bright point slowly fading among the other stars. Ahead, the destination would be another bright point, growing so slowly that for lifetime upon lifetime, it would seem not to grow at all. In between, there would be only the cold gulf, the same star field holding almost still, and the deep silence of a distance too large for any single life, or any 100 lives, to cross. And when at last such a journey ended, what would it have reached? The nearest star is not a grand destination but a modest system of 1 or 2 stars and their own dark spaces, another small island much like our own. Standing there, a traveler would have crossed the very first gap in a galaxy filled with hundreds of billions of stars, and would look out to find all the others still as far away as ever. The nearest crossing, for all its impossible length, would have carried them the smallest imaginable step across the galaxy, from one island to the very next. Set that first step against the whole. Our galaxy stretches something like 100,000 light-years from edge to edge. The crossing to the nearest star is a little over 4 of those light-years. To travel from one side of the galaxy to the other would mean making that already impossible crossing, back to back, more than 20,000 times over. The distance to the nearest star, which already outruns all of human history, is not even a rounding error against the size of the galaxy that contains it. It is the first faint mark on a ruler almost too long to comprehend. Here the impossibility of return begins to make itself felt. Within the solar system, however far we traveled, a journey home could at least be imagined. From the gulf between the stars, that comfort quietly fails. A round trip to even the nearest star would consume far more time than any nation, any language, any memory has ever endured. Whoever set out would leave behind not just a place but an entire world, knowing that nothing they knew could still be waiting when or if they returned. The dark between the stars is a distance measured not in kilometers but in the length of a civilization. It would be easy to let this feel bleak, and it need not. There is another way to hold it. The enormous distance to the nearest star is also the reason the stars keep their peace from one another. Nothing crosses these gulfs easily, and so each star tends its own small system in quiet, undisturbed for ages, separated from its neighbors by an emptiness that protects as much as it isolates. The same distance that makes the crossing lonely also makes the night calm. The stars do not crowd or collide. They hold their stations far apart and turn slowly in the dark. Rest for a moment in that stillness before we go on. The nearest star burns steadily out there, 4 light-years off, our closest companion in all the enormous night, and utterly beyond our reach. Around it and around the sun stretches the same cold gulf we have entered, the true ocean of the galaxy, in which the stars are only sparse and distant lamps. We have taken the measure of the first crossing and found it larger than history. That is the honest scale of the space between the stars, and it is only the beginning of what the dark contains. The nearest star is not quite a single point but a small family of its own, a close pair of stars circling one another with a third, fainter companion drifting far out around them both. It is that faint outermost companion that happens to lie nearest to us, and at least one world is known to circle it, a planet in the closest system to our own. So the very first possible destination beyond the sun is not empty. It has a star and a world waiting at the end of that impossible 4 light-year crossing. To reach it by any means we can imagine would take not one lifetime but many, generation following generation, aboard a single traveling craft. Those who finally arrived would be the distant descendants of those who set out, born and grown old in transit, having known only the journey. They would step out beneath a different sun, never having seen the one their ancestors left. And when they looked back toward the sun, they would see it as it had been years before, its light long delayed by the crossing, for at these distances, every star we see is showing us only its past. Even the simplest message would feel the weight of that distance. A signal sent by radio, traveling at the speed of light, would take more than 4 years to reach the nearest star, and any reply more than 4 years to return, so that the shortest possible exchange of a question and an answer would span the better part of a decade. There could be no conversation across such a gap, only long messages sent patiently into the dark and answered, if at all, by people grown years older. The nearest neighbor we have is already too far away to truly talk to. For the gulf between the stars is not merely empty distance. It is also inhabited, in its own strange and sparse way, by things that belong to no star at all. Out in that unlit country, between the far lamps, there drift worlds with no sun to call their own, wandering alone through the permanent night. They give off no light, and we can scarcely see them, and there may be a great many of them. So let us look now at the wanderers in the dark, the sunless planets adrift between the stars. Part 7. The Wanderers in the Dark. Not every planet belongs to a star. We are used to thinking of worlds as circling a sun, held in a bright family, warmed and lit by the fire at the center. But out in the gulf between the stars, there drift planets that have no sun at all. They are called rogue worlds, or free-floating planets, and they travel alone through the dark, bound to nothing, lit by nothing, following their own slow paths through the emptiness between the far and scattered lamps of the stars. Most of these wanderers were not born alone. They formed, as planets usually do, around a young star, in a crowded early system where many worlds jostled for room. In the gravitational tangles of those early ages, some worlds were flung outward, slung away by the pull of a larger neighbor, and cast out of the system entirely. Once free of their star, they never returned. They fell outward into the dark and kept going, and they have been drifting ever since, exiles from the warm places where they were made. There may be an enormous number of them. The best estimates suggest that free-floating planets could rival the number of the stars themselves, and perhaps even exceed it. If that is so, then the dark between the stars is not the empty void it seems. It is quietly populated with worlds, more worlds than there are suns to light them, a hidden population of planets scattered through the gulfs, each one traveling alone, unseen and uncounted, through the long night between the stars. The sky above a rogue planet is like nothing we know. There is no sun anywhere in it, no warm disk to rise and set, no source of day at all. There is only the deep black, scattered with the distant, unmoving points of far-off stars, the same cold lamps that light the whole of interstellar space. There is no sunrise on such a world, and no sunset, and no turning of the seasons, because there is nothing for the seasons to turn around. It is a world held in permanent, unbroken night, and it has been so since it was cast out, and it will be so for ages yet to come. And yet a sunless world need not be a wholly dead one. A planet carries heat within it, left over from the violence of its formation and generated slowly in its depths, and that inner warmth does not depend on any star. Beneath a thick enough blanket of atmosphere, or under a deep shell of ice, that internal heat could keep a hidden ocean liquid, held in the dark, warmed from below rather than lit from above. It is at least possible that somewhere out in the drifting dark, beneath the frozen crust of a rogue world, there are quiet seas that have never known the light of any sun. These wanderers are almost impossible to find. A planet gives off no light of its own, and without a star to illuminate it, a rogue world is a dark object against a dark background, nearly invisible in every way. We catch them only by rare and fleeting tricks of gravity, in the brief moments when one drifts almost exactly in front of a more distant star and bends its light for a little while as it passes. For every one we manage to catch in this way, countless others must drift by, entirely unnoticed, dark and silent, never crossing in front of anything at all. There is an unsettling thought hidden in that invisibility. A rogue world could pass through the outer reaches of our own solar system, moving quietly through the cold country beyond the planets, and we would very likely never know it was there. It would give off no light to see, and make no sound to hear, and unless it happened to pass almost directly in front of a background star, nothing would betray its presence. The dark that surrounds us may carry more traffic than we can detect, whole worlds slipping silently past, unseen in the emptiness. Held gently, though, this is less a menace than a quiet marvel. These wandering worlds are not hunting anything. They drift where the gulf carries them, indifferent and slow, following paths set in motion long ago. They are simply there, sharing the dark, a scattered and secret population of planets, keeping their own long nights. The gulf between the stars, which seemed so empty when we entered it, turns out to be softly crowded after all, with more worlds than suns, most of them dark, most of them alone, most of them forever unseen. We find these wanderers, when we find them at all, in fleeting moments of alignment. As a rogue world drifts almost exactly between us and a far more distant star, its gravity acts as a faint lens, gathering and bending the distant starlight so that the background star seems to brighten for a little while and then fade as the alignment passes. Each such brightening is a single, unrepeatable sighting of a dark world crossing the dark, and from the rare few we catch this way, we reckon that the unseen many must number in the billions upon billions. These free worlds come in a range of sizes, from bodies as large as the giant planets, down to smaller worlds nearer the size of our own, and some may carry moons of their own, small companions traveling with them through the endless night. A moon circling a sunless world would have no day and no reflected sunlight to light its nights, only the faint, far stars and the dark bulk of the planet beside it. It is a strange and quiet picture, a hidden little system drifting alone between the stars, lit by nothing, keeping its own silent company in the dark. The surfaces of these wandering worlds are colder than almost anything imaginable. With no sun to warm them, whatever gases they once held as air may have long since frozen and fallen to the ground, settling as pale frost and snow over a landscape that has never known a dawn. A traveler standing on such a world would find the very atmosphere lying frozen underfoot, the sky utterly black and thick with unmoving stars, and no source of warmth or light anywhere in it, only the deep, patient cold and the silence of a permanent and starlit night. So the emptiness holds worlds as well as distance. We have passed the sunless wanderers now, the exiles of the dark, and they are only one of the strange populations the gulf contains. For the stars themselves do not last forever, and when they die they leave things behind, remnants stranger and denser and quieter than any living star. Ahead of us lie the corpses of stars, the cooling and the crushed, the dead suns scattered through the same dark the wanderers roam. Let us go on toward them, gently, into the graveyard of the stars. Part 8. The Graveyard of Stars. Let us gather the journey so far before we go on, because the trail has led a long way into the dark. We began just above the air, where the emptiness starts. We crossed the wide gaps between the planets and the frozen ring beyond them. We passed the boundary where the sun's wind gives out, and the light-year shell of comets past that, and entered the true gulf between the stars. We measured the crossing to the nearest star and found it longer than history, and we found the gulf itself softly peopled with sunless, wandering worlds. Now we come to what the stars leave behind when they die. For the stars do not last. It is easy to think of them as eternal, the fixed and steady lamps of the night, but every star is slowly burning through a finite store of fuel, and when that fuel runs low, the star must change and end. How it ends depends on how heavy it is. A star like our own sun ends gently, as most stars do. But even that gentle ending leaves behind a strange and quiet remnant, a dead star that will outlast by far the living one that made it. When a star like the sun exhausts its fuel, it first swells enormously, ballooning outward into a bloated giant that swallows its nearest worlds. Then, its outer layers loosening, it sheds them softly into space, casting off great shells of glowing gas that drift away into the dark. What remains at the center is the star's bare core, exposed at last, no longer burning. It is called a white dwarf, and it is a remarkable thing, a dead star about the size of a small planet, yet still holding a large share of the mass of the sun. This is our own sun's future, written plainly in the lives of stars like it. Long from now, after ages more of steady shining, the sun too will swell and shed its outer layers and settle down into a white dwarf, a dense and cooling ember drifting where the blazing star used to be. It will no longer make light of its own. It will only glow with the leftover heat of what it was, fading slowly through the colors, from white toward yellow, toward red, and at last toward dark. The fire that has warmed every living thing will end as a cooling cinder in the quiet. The matter in such a remnant is packed to a density that ordinary experience cannot match. A white dwarf holds the mass of a star inside the volume of a planet, so that every small piece of it is crushed to an enormous weight. And it cools with astonishing slowness. It has so much stored heat and sheds it so gradually into the cold of space that it takes almost unimaginable spans of time to fade. A white dwarf does not go dark in 1,000,000 years, or 1,000,000,000. It lingers, faintly warm, for far longer than the universe has yet been alive. In theory, there is a final state past the white dwarf, colder and darker still. Given enough time, a white dwarf should cool completely until it no longer glows at all, becoming a cold and inert cinder that astronomers call a black dwarf, a truly dead star giving off no light of any kind. But here is the quiet astonishment. The universe is not yet old enough for a single black dwarf to exist. The cooling takes so long that not one white dwarf anywhere has had the time to finish. Every dead star of this kind is still faintly warm. The true and final corpses of the stars are all still waiting in the future. Think of what that means about the age we live in. The sky we know, full of shining stars, is a young sky and a passing one. The dead stars are still warm because there has not yet been time for them to cool. We are living in the bright morning of the universe, when the fires are still lit and the graveyards are still glowing faintly with residual heat. The long, dark, truly cold future, in which the remnants at last go out, has not yet begun. It lies ahead, further off than the mind can reach. There is a strange calm in the graveyard of the stars, once the first unease passes. These remnants are not frightening things. They are the quiet endings of stars, the slow settling of fire into cinder, following a pattern as natural as any in the universe. Our own sun will join them one distant day, and the Earth's long story will have ended ages before that, and none of it is a tragedy so much as a completion, the ordinary and gentle way that stars conclude. The graveyard is not a place of horror. It is a place of rest, on a scale of time too large to fear. The shells of gas a dying star casts off do not vanish at once. For a while they glow, lit from within by the hot bare core now exposed at their center, forming great luminous clouds that drift slowly outward, softly colored, before thinning into the dark over many thousands of years. It is one of the gentler sights the universe makes, the loosened outer layers of a sun-like star spreading into space, glowing quietly for a time, then fading, while the small dense core settles into its long career as a cooling ember. Our own world will not witness that ending from a safe distance. Long before the sun sheds its layers, it will first swell into a bloated giant, growing until it swallows the innermost planets and scorches the rest, and the Earth's long story will have ended in that heat, ages before the white dwarf ever forms. The outer worlds, farther from the growing fire, may survive to circle the cooling remnant in wider and colder orbits than before, quiet survivors turned loose around a dead sun, in a solar system gone dark and quiet at last. As a white dwarf cools across its unimaginable lifespan, something quietly astonishing happens within it. The dense material of its interior, packed to enormous pressure, begins to settle into an ordered, crystalline state, so that the cooling ember slowly turns, over ages, into something like an immense and perfect crystal, a whole dead star gradually setting into solid form. The sun's own distant future holds this strange fate, a slow crystallization in the dark, long after its light has failed, a cinder turning to crystal across spans of time the mind cannot hold. But not every star ends so softly. The gentle white dwarfs are the remnants of ordinary stars, stars like the sun. When a far heavier star dies, its ending is not gentle at all, and what it leaves behind is stranger, denser, and more extreme than a cooling ember by an enormous margin. There are remnants in the dark that crush matter itself past the point where atoms can survive. So let us go on, deeper into the graveyard, toward the crushed stars, where the dead become something almost impossible to believe. Part 9. The dim and the failed. Before we reach the crushed stars, it is worth lingering in the dimmer corners of the graveyard, among the objects that never shone brightly to begin with. Not everything in the dark between the stars is a blazing sun or the remnant of one. Scattered through the same gulfs are the dim and the failed, objects that gathered like stars but never quite became them, glowing only weakly, or not at all, in the long night. They are easy to overlook, and there are a great many of them. Chief among these are the failed stars, the ones that formed from collapsing clouds of gas but never grew heavy enough to light their own fires. A true star shines because its core is crushed hard enough to fuse and blaze. These smaller bodies never reached that threshold. They are larger than planets and smaller than stars, and they give off only a faint warmth, glowing dimly in colors the eye can barely register, slowly cooling as the ages pass. They drift through the dark half-lit, neither worlds nor suns, a quiet population between the two. Alongside them drift the cooling remnants of stars that have already died, the white dwarfs we have met, and others like them, scattered thinly through the galaxy wherever old stars once burned. Add to these the sunless wandering worlds we passed earlier, and the ordinary dark bodies of dust and rock and ice, and a surprising picture emerges. A great deal of what the galaxy actually contains gives off almost no light at all. The shining stars catch the eye, but around and between them drifts a much quieter population of the dim, the failed, and the dead. Given enough time, that quiet population is the one that endures. The bright stars are spending their fuel, each of them burning toward its own ending, and no star lasts forever. The dim and the dead, by contrast, simply persist, cooling so slowly that they outlast the living stars by spans of time almost beyond meaning. Look far enough into the future, and the balance tips completely. The blazing sky thins and dims, the fires go out one by one, and what remains is the long reign of the remnants, the cinders and the failed and the dark. This is the deep future of the galaxy, and indeed of every galaxy, sketched in the objects we can already see. The star-filled night is a phase, not a permanent condition. It belongs to the young universe, to this bright early age when the fuel is still plentiful and the fires still burn. In the long run, the darkness inherits everything. The cooling embers and the failed stars and the wandering dark worlds outlast the light by an amount of time so enormous that the whole present age of the universe is only a brief flicker at its start. It would be easy to hear that as a bleak forecast, and gentler to hear it truly. The coming of the dark is not a catastrophe, but a settling, the slow quieting of a universe that began in fire and cools, patiently, toward rest. There is nothing violent in it. The stars are not destroyed so much as spent, each giving its light for its allotted age and then subsiding into cinder. The long darkness ahead is not an ending imposed from outside. It is simply what fire becomes, given time enough, and time is the one thing the universe has without limit. For now, though, we live among the lit stars, and the dark remnants are only a scattered minority, glimmering faintly here and there through the gulfs. It is a strange privilege, in a way, to travel through the graveyard while the fires still burn, to pass the dim and the failed and the cooling dead while the sky overhead is still crowded with living light. The deep, dark future is real, and it is coming, but it is unthinkably far away, and this night, and every night we will ever know, falls within the bright and early morning of things. Hold that thought softly as the dim shapes drift past. The failed stars glow faintly in the dark, the old cinders cool by imperceptible degrees, the sunless worlds wander on, and none of them disturb the quiet. They are the patient inheritors of the universe, waiting through ages we cannot picture for a darkness that has not yet come. And among them, scattered through the same graveyard, are remnants of a wholly different and far more extreme kind, the crushed cores of the heaviest stars, where matter is pressed past every ordinary limit. The failed stars are worlds of slow weather. Too small to burn, they cool gradually over the ages, and as they cool, clouds form and shift in their thick atmospheres, and storms turn slowly across them, all of it glowing only in a heat too deep for the eye to see. They are neither the bright company of stars, nor quite the dark stillness of planets, but something patient in between, dimming by imperceptible degrees, across spans of time longer than the present age of the universe, giving off their faint warmth to no one. And the making of new stars, which lights the galaxy, cannot go on forever. Each new generation of stars is built from the gas left between the older ones, and that gas is finite, slowly used up and locked away in remnants that will not give it back. Far in the future, the raw material will run low, and fewer new stars will form, until at last the galaxy makes no new light at all. The dimming is not sudden, but it is certain, a slow turning down of the lamps across an immensity of time we can name but never truly feel. These dim, failed stars may be far more common than their faintness suggests. Because they give off so little light, they are extraordinarily hard to find, and yet the few we have managed to detect hint that the dark is thick with them, perhaps nearly as many as the true stars, scattered unseen through every corner of the galaxy. For each faint one we notice nearby, many more must drift beyond our reach, cooling quietly in the dark, a huge hidden population of near-invisible worlds that shine too weakly for us to easily count. There is, in truth, no sharp line where planets end and stars begin. The universe makes a continuous range of bodies, from small cold worlds up through larger ones, up through the failed stars that never quite caught fire, and only then to the true stars that burn. Across most of that range, the bodies give off little or no light of their own, growing brighter only near the very top, where at last the fires are lit. So the shining stars are the rare, bright endpoint of a long, dim ladder, and most of the rungs below them belong to the dark, populated by worlds and near stars that glow faintly or not at all. So we come at last to those crushed stars, the strangest tenants of the graveyard. They are small and dense beyond belief, the collapsed hearts of stars far heavier than the sun, and the physics that rules them is unlike anything in gentle daily life. A spoonful of one would outweigh a mountain. Some of them spin hundreds of times a second. The most extreme of them carry forces that could unmake the atoms of a body from a great distance. Let us go carefully on toward them now, into the country of the crushed stars. Part 10. The crushed stars. When a star much heavier than the sun comes to the end of its life, it does not settle gently into a cooling ember. Its core, no longer able to hold itself up, collapses inward with tremendous force, falling past the point where a white dwarf could form and crushing its own matter far beyond. The pressure grows so extreme that the atoms themselves give way, their structure crumbling under the weight. What remains, when the collapse finally halts, is one of the strangest objects in all of nature, a neutron star. The numbers are almost impossible to hold in the mind. A neutron star packs about as much matter as the whole sun into a sphere only some kilometers across, no larger than a single city laid out on the Earth. All that mass, all that substance, squeezed down into so small a ball, reaches a density unlike anything in ordinary experience. A single spoonful of neutron star material would weigh about as much as a mountain, something near 1 billion tons, gathered into the space of a teaspoon. It is matter pressed to the very edge of what matter is able to be. On such a surface, the pull of gravity is beyond all comparison with anything we know. It is so strong that the whole star is drawn into a nearly perfect sphere, and the tallest rise anywhere on it, its highest mountain, would stand no more than a few millimeters above the surrounding surface. A pebble falling from even a small height would strike the ground, moving at a speed that no earthly fall could match. Everything about a neutron star is extreme: its density, its gravity, its smoothness, pushed to limits that the gentle physics of daily life never approaches. Many of these crushed stars also spin, and spin astonishingly fast. When a large, slowly turning star collapses into so small a ball, its turning speeds up enormously, in the same way that a spinning skater draws in and quickens. A neutron star can rotate not once a day or once an hour, but dozens or even hundreds of times every second, whirling so fast that the mind can scarcely picture it. A city-sized sphere as heavy as the sun, turning hundreds of times in the space of a single breath, is one of the fastest large motions anywhere in the universe. As they spin, many neutron stars sweep beams of radiation out into space, streaming from their magnetic poles like the turning beam of a lighthouse. If one of those beams happens to point our way, we catch it not as a steady light but as a pulse, a flash arriving each time the star turns to face us, over and over with astonishing regularity. When these regular pulses were first noticed, arriving with such precision, they were so steady and so clock-like that for a little while their nature was a genuine puzzle. They turned out to be these spinning remnants, sweeping the dark with clockwork beams. Such a pulse is among the most reliable rhythms in nature. A spinning neutron star can keep time so steadily, turning with such even regularity, that it rivals the finest clocks ever built. Out in the dark, these crushed stars turn and flash, marking out their impossibly fast rhythm for ages on end, indifferent to whether anything is watching or listening. They are cosmic clocks that no one wound and no one tends, keeping perfect time in the emptiness, the steady heartbeats of the graveyard of stars. It is worth remembering, standing near one of these in the imagination, that none of this power is aimed at anyone. A neutron star crushes and spins and beams not out of any purpose but simply because that is what it is, the natural remnant of a heavy star's death. Its extremity is a fact of the place, not a threat directed outward. The nearest of them lies safely far away, hundreds or thousands of light years off, turning in their own remote corners of the dark, and the beams they sweep through space pass mostly through emptiness, touching nothing, meaning nothing by it. Here the escalation of our journey becomes plain. We began among warm and gentle worlds, and we have come, step by step, to stars so dense a spoonful outweighs a mountain, spinning hundreds of times a second in the dark. And these are not freakish rarities gathered at the edge of the map. They are ordinary stars, only somewhat heavier than the sun, taken to the natural end of their kind. The universe makes such things routinely, scattering them through every galaxy, the commonplace corpses of its heavier suns. A neutron star is not a smooth ball of uniform stuff, but a layered world with a solid crust over an interior stranger than any material on Earth. That crust is rigid and immensely strong, and now and then it settles or cracks under the strain of the star's furious spin, causing the whole star's rotation to shift by a tiny, sudden amount, a faint stumble in an otherwise perfect rhythm. Even the steadiest clocks in the universe, it turns out, have their small and quiet irregularities, betraying the restless solid worlds hidden beneath the beams. Each of these crushed stars was born in the violent death of a much larger one. When a heavy star collapses and its outer layers are cast off into space, the core left behind is the neutron star, flung into the dark and often set moving at great speed by the very event that made it. So these remnants are the seeds of catastrophe, the small, dense hearts of stars that ended long ago, scattered across the galaxy, spinning and beaming quietly for ages afterward, each one the surviving center of a fire that went out. The fastest of these crushed stars turn at speeds that strain belief. Some spin so quickly, hundreds of times each second, that a point on the star's surface sweeps around at a large fraction of the speed of light, the whole small world whirling at the very edge of what its own fierce gravity can hold together. They are as fast as nature seems willing to spin a solid thing, tiny dense stars turning at the threshold of flying apart, held together only by the same crushing gravity that made them, kept in perfect balance between speed and weight. And even the neutron star, extreme as it is is not the most extreme thing the dark contains. Among these crushed remnants, there are some that carry a further property, a magnetic force so powerful that it stands alone as the strongest of its kind anywhere in the known universe. These are the magnetars, and what their fields can do, even across great distances, is difficult to believe. So let us step carefully closer, in the imagination only, and consider the strongest magnets in all of nature. Part 11. The strongest magnets in the universe. Among the crushed remnants of the heaviest stars, a rare few carry something extra, a magnetic field of almost incomprehensible strength. These are the magnetars, neutron stars whose magnetism stands as the most powerful of any object known anywhere in the universe. Every neutron star is strange, but a magnetar is stranger still, wrapping its already extreme body in a force so intense that it reshapes the space around it and everything that might drift too near. It is the crushed star, taken one step further, into a country of force we have no earthly comparison for. The strength of that field resists any ordinary description, so let its effects speak instead. From as close as 1,000 kilometers, a magnetar's magnetism would reach into the atoms of a human body and distort them, stretching and reshaping the delicate structures on which all ordinary chemistry depends, until the chemistry that sustains a living thing could no longer function at all. It would not need to touch you, or heat you, or strike you. Its field alone, at that distance, would quietly unmake the atoms you are built from. No force we handle in daily life comes within an enormous factor of it. The reach of that magnetism is difficult to overstate. Were one of these objects placed a good part of the way to the moon, its field would still be strong enough to wipe the information from every magnetic stripe on the far side of the Earth, scrambling stored data across a whole world from an enormous distance. That a single small sphere, no larger than a city, could reach across such a gulf and touch the Earth, so is a measure of a force that belongs entirely to the extremes of the universe, and never to the gentle middle where we live. From time to time, a magnetar stirs. The immense strain of its magnetic field can crack the rigid crust of the star in a sudden shift, a kind of starquake, and release a burst of energy into space. In a brief moment, such a flare can pour out more than the sun gives off across a great span of time, a short, immense pulse of radiation crossing the dark. These outbursts are rare, and they come from remnants scattered far across the galaxy, and by the time their light reaches us, it has been thinned by the enormous distance into something faint and safely remote. For all this power, a magnetar, like everything else in the deep, is entirely indifferent. It does not seek anything out. It spins and blazes and strains and now and then flares, because that is simply the nature of what it is, a heavy star's corpse wound in impossible force. Whether or not anything lies near enough to be undone by it makes no difference to the magnetar at all. Its violence is a property of the place, not an intention, and it plays out in the dark whether or not there is anyone anywhere to know of it. And, as always on this journey, distance is our shelter and our peace. The nearest magnetars lie tens of thousands of light years away, so far off that their terrible fields, which would unmake a body from 1,000 kilometers, reach us only as faint signals gathered by patient instruments. We can study them precisely because they are remote. Their power is real, and among the greatest in the universe, and it is also utterly out of reach, sealed away behind gulfs of distance so enormous that it can never trouble the quiet of this night. Notice, again, how far the ladder has carried us. We began among warm worlds under a friendly sun. We have arrived at objects whose mere presence, at a distance of 1,000 kilometers, would dissolve the atoms of a living body, and whose magnetism can reach across a good part of the way to the moon. Each step outward and downward has led to something more extreme and more indifferent than the last, and yet each has also proved to be safely, immensely far away, held at a distance the mind can barely span. These magnetars are, in a sense, the most forceful things the graveyard of stars contains, the loudest of its silent tenants. And still they are not the deepest place the dark can reach. For when a star is heavier even than those that leave neutron stars behind, its ending does not stop at a crushed and magnetic sphere. Its collapse continues past every limit, folding space around itself until it forms a place from which not even light can return. Beyond the crushed stars lies the deepest rung of all, and it is there we turn next. A magnetar does not keep its terrible power forever. Its magnetism, immense as it is, slowly drains away over time, and so a magnetar is fierce only for a relatively short chapter of its long life before it fades into a quieter kind of neutron star. In the whole population of crushed stars, the truly magnetic ones are rare and briefly active, a small and short-lived minority, which is part of why the nearest are so far away, scattered thinly across a galaxy that has few of them lit at any one time. Even so, their reach can be felt across enormous distances. On rare occasions, one of these objects releases a giant flare, a single immense burst of energy, and one such flare, arriving from far across the galaxy, once briefly disturbed the outermost edge of the Earth's own air, before passing on, its source so distant that it posed no danger at all. That a crushed star tens of thousands of light-years away could reach across such a gulf and lightly brush our planet's upper air is a quiet measure of how far the extremes of the universe can extend their touch. Only a small number of these magnetic stars have ever been found, and we know them mainly by their outbursts. Most of the time, a magnetar is quiet, betraying itself only now and then with a sudden burst of high-energy light, a brief flare from a settling of its strained crust, before falling silent again. Between these rare flashes, they are difficult to see at all, and so the true number scattered through the galaxy is uncertain. They are among the rarest and briefest of the crushed stars, lighting up for a moment and then keeping their long silence in the dark. So let us leave the magnetars turning in their far corners of the dark, their impossible fields reaching out into an emptiness that mostly holds nothing to touch. We have seen how extreme an ordinary star's death can become. Ahead lies something that is not merely extreme but final, a kind of place rather than a kind of star, where the rules of light and motion that have held throughout our whole journey quietly come to an end. Ahead lie the black holes, the places where light itself stops. Part 12. Where light stops. For the very heaviest stars, not even the neutron star's crushed matter can hold the line. When such a star dies and its core collapses, there is nothing left strong enough to halt the fall. The matter caves inward, past the point where atoms failed, past the point where even the crushed substance of a neutron star could resist, and keeps collapsing without any limit we know. Around the vanishing core, space itself folds so steeply that a boundary forms, a threshold beyond which nothing at all can return. This is a black hole, the deepest thing the dark contains. The boundary has a name, the event horizon, and it is unlike any edge in ordinary life. It is not a surface you could land on or touch, not a shell of matter, not a wall. It is a line drawn in space itself, marking the place beyond which every possible path leads inward. Cross it, and there is no longer any direction that leads back out, not because the way is blocked, but because outward has ceased to be among the directions that exist there. Every road past that line runs deeper in. There is simply no path that returns. Even light, the fastest thing there is, cannot escape from within that boundary. This is what makes a black hole black. Light that crosses the horizon can never climb back out to be seen, and so the region within is not dark in the way a shadow is dark, but dark in a deeper way, cut off from the rest of the universe entirely. From outside, a black hole shows only its edge, a perfectly lightless boundary against the stars, marking the place where everything that falls in disappears from the universe for good. Near a small black hole, gravity changes so sharply from one place to the next that it pulls unevenly on anything approaching. A body falling in would feel its near side drawn far more strongly than its far side, and would be stretched out lengthwise while being squeezed from the sides, drawn into a long, thin thread. The effect has been given a gentle, almost playful nickname, but it marks a real and absolute limit, the distance at which ordinary objects can no longer hold themselves together and are pulled apart by the steepness of the pull. It is startling to learn how near the closest of these places actually is. The nearest black hole we have so far found lies a bit more than 1,000 light-years from the Sun. That is far too distant to have any effect on us, an enormous gulf by any human measure, and yet it is closer than a great many of the stars we can see and name in the night sky. Somewhere out there, nearer than much of the familiar constellation work of the heavens, sits a place where light and motion simply end, quiet and unremarkable against the dark. It is worth setting aside one common picture, because the truth is calmer than the myth. A black hole is not a cosmic mouth roaming the galaxy and pulling things into it. Its gravity at any given distance is no stronger than the gravity of the star that made it. A world could orbit a black hole steadily and safely for ages, circling it as calmly as a planet circles a sun, so long as it kept its distance. A black hole does not chase or hunt. It is far less a predator than a place, and a still one, holding its position in the dark and simply being what it is. And what it is, at heart, is the stillest place in all of the universe. Everything we have traveled through has been in motion, the turning worlds, the streaming wind, the spinning crushed stars, the drifting wanderers. A black hole is where motion itself finally comes to rest. Past its boundary there is no going back, and, in a sense, no going anywhere but inward and down, toward a quiet the rest of the universe can never reach or disturb. It is not a place of violence so much as a place of ultimate stillness, sealed away behind a boundary that lets nothing out. Held that way, a black hole is not a thing of horror, but a thing of hush. It is the deepest silence the cosmos offers, the one kind of place from which no light, no signal, no motion ever returns to trouble the night. It keeps whatever falls into it in perfect and permanent quiet, forever beyond reach, forever beyond sight. Of all the far and extreme places we have traveled toward, it is the most complete in its stillness, and, once the first strangeness passes, strangely the most peaceful. Time itself behaves strangely near the boundary of a black hole. To a distant watcher, an object falling toward the horizon appears to slow as it approaches, its motion stretching out, its light draining toward red, until it seems to hang almost frozen at the very edge, dimming forever, without ever quite being seen to cross. The infalling object, for its part, notices no such thing and passes smoothly inward. Near a black hole, even the flow of time, the one thing that seems most fixed in ordinary life, bends and stretches and loses its common meaning. For all their power, the black holes left by dying stars are physically small. The boundary of such a hole, the horizon from which nothing returns, may be only kilometers across, a dark sphere smaller than a city holding the mass of several suns. And what lies at its center, where the collapse ran on without limit, is a place our understanding cannot yet follow. There, the rules of space and time as we know them give out, and the honest answer is that we do not know what a black hole is at its very heart. It is a genuine edge of knowledge, sealed behind an edge of the world. If a traveler could fall toward one of these boundaries and look back outward, the view would slowly transform. The stars behind and around would seem to gather and crowd toward a single bright region overhead, the whole of the outside sky compressing into a shrinking circle of light as the darkness closed in around it. It would not be a violent sight, but a strangely quiet one, the universe folding itself into a bright ring above, while everything below fell away into a dark from which no glance and no light could ever return. We have reached then the deepest rung of the dead stars, the place where the ladder of collapse finally ends. But black holes are not always found in the bright and studied pairs where we can most easily see them. Many drift alone and unlit, giving off nothing, betraying their presence only by the faint bending of starlight behind them as they pass. Some wander the galaxy freely, dark travelers moving through the same emptiness the rogue worlds roam. So let us look now at the hidden and the wandering, the lone black holes adrift in the dark. Part 13. The hidden and the wandering. The black holes we can point to are the ones that give themselves away. They betray their presence by their effect on a nearby star or by the glow of matter falling toward them, and so we can find them and study them from far off. But these are only the ones that happen to sit where we can notice them. Many black holes give off no such signs at all. They drift alone in the dark, with no companion star to disturb and nothing falling in to glow, and they are, to nearly every method we have, completely invisible. A lone black hole is a difficult thing to find, precisely because it does nothing to announce itself. It emits no light of its own. It makes no sound and sends no signal. The only trace it leaves is a subtle one. As it passes in front of more distant stars, its gravity bends their light a little, warping and brightening the view behind it for a short while before moving on. That faint distortion in the sky is very nearly the only fingerprint such an object leaves, and catching it requires looking at exactly the right patch of dark at exactly the right moment. Some of these black holes do not merely sit still, but wander. The violent events that create them can give them a kick, flinging the new black hole away from its birthplace, and long gravitational tangles with other objects can set them adrift as well. So there are black holes traveling freely through the galaxy, moving through the same emptiness that carries the sunless rogue worlds, but carrying with them a boundary from which nothing returns. They are the strangest travelers the dark contains, drifting quietly along their paths, dark upon dark. A wandering black hole would offer almost no warning of its approach. Because it gives off no light, nothing about it could be seen directly, coming or going. It would be found, if at all, only by that faint bending of the light of stars behind it as it crossed in front of them, and only by an observer who happened to be watching that exact stretch of sky. The nearest such wanderers are, as with everything on this journey, safely and enormously far away. But their sheer silence, the way they move unseen, is a quiet and particular kind of unease. This is the deepest rung of the local dark, and a fitting place to pause and look back at the whole descent. We began just above the air, where the emptiness starts, and crossed the wide gaps between the planets. We passed the frozen ring and the boundary of the sun's wind, and the light-year shell of comets beyond it. We entered the gulf between the stars and measured the crossing to the nearest one, and found the gulf softly peopled with sunless worlds. We reached the graveyard of stars, the cooling embers and the failed, the crushed and spinning remnants, the strongest magnets in the universe, and at last the places where light itself stops. Every one of those steps had the same shape, repeated over and over on a larger scale. Each carried us farther from home than the last. Each led into deeper emptiness than the one before. Each introduced objects stranger, denser, more extreme, and more entirely indifferent than those we had already passed. And with each step, the possibility of ever returning grew fainter, until it faded past any real meaning at all. That is the pattern the title of this journey names, the plain fact that the farther out we travel, the stranger and emptier and less returnable the universe becomes. And here is the part that ought to be kept gently in view. For all that descent, all those escalating extremes, we have not yet left our own small corner of a single galaxy. Everything we have passed, the planets and the comet cloud, the nearest star and the wanderers, the crushed stars and the black holes, lies within a modest neighborhood of the Milky Way, one galaxy among a great many. The whole enormous journey so far has been, on the scale of the universe, a few short steps from the front door into the nearest patch of the surrounding dark. That thought is meant to steady rather than to daunt. The extremes we have met are real, but they are also local, near neighbors by cosmic reckoning, and they are all safely, immensely far from this quiet night. And ahead of us, if we keep traveling, the scale opens out again, far beyond anything the single objects prepared us for. For there is the whole span of the galaxy to cross, and then the emptiness between the galaxies, and then the great voids where even galaxies run out. The largest quiet still lies ahead. The galaxy has been making black holes for a very long time, one for every heavy star that has lived and died across its history, and that history is long. So there may be a great many of them drifting through the Milky Way, most of them old and dark and utterly quiet, long since parted from whatever companions they once had. They are not rare monsters, but a steady, accumulating population, the settled remnants of countless vanished stars, moving unseen through the same dark that holds everything else. Their invisibility, rightly understood, is a comfort as much as an unease. The galaxy is so enormous, and its wandering dark objects so widely scattered, that the distance between any two of them is immense, and the chance of one drifting near our small corner is vanishingly small. The nearest we know of are far beyond any reach, and the dark travelers keep to the wide emptiness, passing one another across gulfs so large that they almost never meet. The quiet that hides them also keeps them, and us, safely apart. Now and then a wandering black hole might give a fainter sign of itself. Should one drift through a thin cloud of gas, some of that gas could be drawn in and heated as it fell, glowing faintly for a while, and marking, indirectly, the presence of the unseen traveler. But most of the dark wanderers move through emptiness, with nothing near enough to draw in, and so they cross the galaxy in complete silence, giving off no light and stirring nothing, their passage known to no one, betrayed by nothing at all as they go. So let us lift our view now from the single objects to the shape of the whole. We have spent this journey moving among individual things, worlds and stars and their remnants, one at a time. It is time to pull back and see the immense wheel that holds them all, the galaxy itself, and to feel how small even our long descent has been against its size. Let us rise above the local dark and look at the Milky Way entire, the great turning island of stars in which our whole journey has, so far, been contained. Part 14. Lost in the Galaxy. Draw back now from the single objects and consider the whole system that contains them. Our galaxy, the Milky Way, is a turning wheel of a few 100 billion stars, gathered into a broad flat disk with a bright bulge at its center and long arms curving outward through the dark. It is so wide that light, moving at its unmatched speed, needs something like 100,000 years to cross from one edge to the other. 1,000 centuries of travel for the fastest thing in the universe only just spans the width of our home island of stars. Enormous as it is, and packed with hundreds of billions of stars, the galaxy is still almost entirely empty space. The stars within it are so tiny compared to the distances between them that a galaxy is far more gap than substance. This is why, when two galaxies drift into one another, they do not shatter in a great collision. They pass through each other, almost like two clouds of thin mist, their stars gliding past in the wide dark, and hardly a single star ever strikes another. Even a galaxy, crowded as it looks, is mostly nothing at all. Our own sun sits far out toward the edge of this wheel, in one of the long spiral arms, in a quiet and unremarkable stretch of the galaxy, well away from the crowded center. From there, it circles the galactic heart slowly, carried around on the turning of the whole disk, taking something like 200 million years to complete a single enormous lap. In the entire long life of the Sun so far, through all the ages since it first caught fire, it has managed only a couple of dozen of those laps. The galaxy turns on a clock that dwarfs the lives of stars. At the very center of the wheel, around which everything else slowly turns, sits a black hole unlike the ones we passed in the local dark. It holds not a few times the mass of the Sun, but millions of times as much, an enormous heart of darkness ringed by densely crowded stars and hidden from our view behind thick lanes of dust. It is the still anchor of the whole galaxy, the fixed point about which hundreds of billions of stars, including our own Sun, trace their long and patient orbits through the ages. Around and above the bright disk hangs something dimmer and even larger, a great rounded halo of sparse old stars and tight ancient clusters, scattered thinly through a region wider than the visible wheel itself. Out in that halo, the stars are few and far between, and the dark is enormous, an outer country far quieter and emptier than the crowded disk below. A star adrift in the halo would look down upon the whole bright wheel of the galaxy from outside and above, alone in the sparse dark, with the crowded lanes of light spread out far beneath it. Set our long journey against all of this, and it shrinks almost to nothing. Everything we traveled through, the whole descent from the planets to the black holes, took place within a small neighborhood of the disk, a short reach of one spiral arm. Against the full width of the galaxy, 100,000 light-years across, that neighborhood is a single quiet point. We could travel as far again and again and again, thousands of times over, and still be crossing the same one galaxy among the hundreds of billions of stars it holds. There is a particular feeling that comes with grasping the size of the galaxy, and it is not quite fear. It is the sense of how thoroughly a single world can be hidden. Our Sun is one ordinary star among a few hundred billion, set far out in a common part of the wheel, unremarkable in every way that would catch a distant eye. The Earth, our whole world, is a speck circling that one ordinary star, lost somewhere in an arm of a galaxy so wide that light itself takes 1,000 centuries to cross it. To see the galaxy whole is to feel how small and how well concealed a home can be. Our galaxy is not entirely alone in the dark. It belongs to a small gathering called the Local Group, a loose family of galaxies bound together by their mutual pull, holding a couple of large spirals and a few dozen smaller companions in a slow, shared dance. This little cluster is held together tightly enough that the great expansion of the universe cannot pull it apart. Its members will stay bound to one another, even as the rest of the cosmos drifts away, a single island of company in a widening sea. The largest of our neighbors is another great spiral, so far off that its light takes millions of years to reach us, and yet it is drawing slowly nearer, falling toward us across the dark. Far in the future, the two galaxies will meet and slowly merge, their stars gliding past one another through the immense gaps, over hundreds of millions of years, until at last they settle into a single larger island of stars. It will be a union without collision, a slow folding together, unfolding so gently and so slowly that no single night within it would show any change at all. Scattered through the dim outer halo of our galaxy hang some of the oldest things in it, the globular clusters, tight and ancient knots, each holding hundreds of thousands of stars gathered into a single glowing ball. These clusters are far older than the flat, bright disk where the Sun lives, survivors from the galaxy's earliest days, orbiting quietly high above and below the crowded lanes of light. To stand within one would be to see a sky crowded with stars far denser than our own, an ancient company keeping its slow watch in the lonely outskirts of the galaxy. And yet this is only one island of stars. The galaxy, for all its hundreds of billions of suns and its 100,000 light-year span, is a single member of a much larger gathering, one wheel among a great many turning in the dark. Beyond its edge, the emptiness does not end but deepens, opening into gulfs beside which even the crossing between stars looks small. For between the galaxies lies a space emptier than anything within them, and beyond the nearest galaxies lie the largest empty regions the universe contains. Let us take the last step of our journey, out past the galaxy, into the emptiness between the islands of stars. Part 15. The emptiness between galaxies and the long quiet. Beyond the edge of the galaxy, the emptiness reaches its full and final depth. As sparse as the space between the stars was, the space between the galaxies is emptier still, a near-perfect nothing stretching across gulfs so wide that the crossing between neighboring stars would be lost within them many times over. Between one island of stars and the next lie millions of light-years of almost total vacuum, dark and cold and still, holding scarcely anything at all across distances that make even a galaxy seem small. On the largest scale, the galaxies are not scattered evenly through this emptiness, but gathered into a great pattern. They cluster into groups, and the groups into larger clusters, and the clusters string together into immense threads and walls that stretch across the universe, bright filigrees of galaxies woven through the dark. And between those bright threads lie the voids, enormous rounded regions of near-total emptiness, some of them hundreds of millions of light-years across, holding almost no galaxies at all, the great hollow spaces around which everything else is draped. One such void is so enormous that it is difficult to place beside anything familiar. If our own galaxy sat at its center, the nearest other galaxies would be so far away, so faint and so sparse, that for most of our history we might have believed we were nearly alone, with almost nothing else in the sky to see. It is a bubble of near nothing, roughly 300 million light-years wide, a hollow in the universe so large that a galaxy adrift in its middle would have found the rest of creation nearly beyond the reach of its sight. And this emptiness is not fixed. It is growing. Space itself is expanding, stretching steadily in every direction, and as it stretches, it carries the distant galaxies apart from one another, widening every gulf between them. More than that, the expansion is quickening, gathering pace as the ages go by. The most remote galaxies are already receding from us faster and faster, drawing away across a widening dark, moving beyond any hope that anything could ever cross the growing distance to reach them. Follow that expansion far enough into the future, and it leads to a profound and gentle isolation. The galaxies now visible in our sky will, in time, be carried so far away, and so quickly, that their light will no longer be able to reach us at all. One by one, they will slip past the edge of what can ever be seen, fading from the sky until they are simply gone from view. A far future observer would look out and find the surrounding universe nearly empty, the other islands of stars having drifted beyond the horizon of sight, each galaxy left alone in an ocean of dark too wide to cross. That is the direction in which the whole universe is quietly tending, toward more space and fewer neighbors, toward deeper emptiness and longer silence. It is the final and largest form of the pattern we have followed all night. The farther out we have traveled, the emptier things became, and the harder any return grew, and on the greatest scale of all, the emptiness is not only enormous, but increasing, carrying every island of stars slowly away from every other, forever. The universe's long story bends, gently and without malice, toward quiet. On the very largest scale we can map, the galaxies trace out a pattern of astonishing structure, gathered along immense threads and sheets that stretch across enormous reaches of space, with the great empty voids hollowed out between them. Strung along those bright threads, galaxy after galaxy, the arrangement looks almost like a web spun across the universe, the largest structure there is, woven of islands of stars and the dark that lies between. And most of the volume, by far, belongs not to the threads but to the empty spaces they enclose. Follow the long future of it all, and even the bright threads dim. Ages from now, after the last new stars have formed and burned and faded, after the remnants have cooled toward true darkness, the universe will settle into a long, cold quiet, an immensity of remnants and empty space, still expanding, still cooling, holding its stillness across spans of time, beside which the entire present age of the cosmos is only a first bright instant. It is not an ending so much as a settling, the universe growing slowly quiet the way an evening does. It is worth holding at the end how gentle all of this slowness is. Nothing in the great emptiness happens quickly. The galaxies drift apart over billions of years, the stars cool over spans longer still, and the voids widen so slowly that from within a single lifetime, nothing at all appears to move. The universe empties and quiets, not with any violence, but with the patience of something that has all of time to do it in, so unhurried that its immense changes are, to any single night, perfectly and completely still. And here, at the very end of the journey, the unease and the peace we have carried finally become the same thing. The universe is mostly emptiness, cold and enormous and forever growing, and it holds its extremes, its crushed stars and its lightless boundaries at distances no life could ever cross. All of it is indifferent to us. And that indifference, which might have seemed frightening at the start, turns out to be the deepest comfort of all. The great dark is not reaching for you. It asks nothing of you. There is nowhere out there you must go, and nothing out there you must do. So we let the deep stay where it is, far below us and far around us in the dark. The empty gulfs remain empty. The sunless worlds drift on through their permanent night. The crushed and silent stars keep their far stations, and the lightless boundaries hold their perfect stillness, and the great voids go on quietly widening, all of it turning slowly and asking nothing of anyone. It was there long before this night, and it will be there long after, and none of it needs you to watch over it or worry for it. There is nowhere you need to travel now, and nothing out there you need to reach. The whole enormous dark, with all its distance and all its strangeness, can be set down and left where it lies. Let the distances settle. Let the cold, far places keep themselves. Let your breathing slow, and let your thoughts grow quiet, and let the great and gentle emptiness of the universe hold you softly where you are. There is nothing to cross tonight, and nothing to fear in the dark. Rest now. Sleep well, and good night.